So what I want to do today is to port another example from Raylib. Let's remember Raylib is this C library that works basically like it's kind of like a game library, a graphics library. You know what I love it the most is it makes it really easy to actually open windows and throw things in it. It has plenty of other stuff, for audios and graphic interfaces, math, like 3D and all that stuff. But the cool thing is that it's written in C. It's very simple to use, has no dependencies, works on every platform. Pretty cool. So what we are trying to do is to basically we're using it in Swift, as you can see here. This is just Swift code. And what I'm trying to do today is to port one of the examples because we have been porting a bunch of them already. So all of these are examples that are basically taken from this page. So I started by the first one, like simple opening windows, and now I'm basically here, where what I'm trying to do is today we're gonna try to make a 2D platformer using this example. So let's see how that goes. So to do this, let's start taking a look at what do we need. So it's defining a player, an environment item, which I guess it's just, obstacles and stuff like that. And then we have the update player, update camera. Yeah, because the fun thing about this one is how the camera updates and tracks the player. So let's take a look at that. So we start with a typical initialization with the camera size. We start opening, setting up the window, and we are setting up, a bunch of data. Then we set up the camera. These are like pointers to the functions above. So this is basically like seems like it's just an array of closures. That's what we're going to be using in Swift, I guess. And then based on this camera option, is going to use one of these ones. That makes sense. Okay. Based on this, set FPS. Okay. And yeah, we start using the delta time and all that. Okay. What I want to start with is to make it simpler for me, I guess. Tackle basically the environment first and then the player, or we just follow here and copy paste things and try to make it work. I'm not so sure. I think I'm gonna try to start with the player. Let's see. So for the player, let's have a struct player. That's gonna be a good start. And what does the player has? These are the update functions that, as you can see, they are a bit complicated. But for now, let's just focus on this. So the player has a position, which is a vector 2. It has a speed. Can jump. Okay. And that's a player. That's it. Okay. So with the player done, the player should have an update function. Okay. The update function is here. So let's just put the function on the player itself for now. I think it's like, a little bit of object orientation, but I don't want to think about that. So the player itself, and then we need environment items. Okay. Environment, I will just call it environment for now. And I guess this is a pointer to an array. Yeah, because this is the pointer to the start of the array and this is the length of the array. So, typical C. And the delta, I guess, is the delta time. which I'm just gonna call it. I prefer to call time. I'm gonna call it delta time because that's what I usually, I guess I'm used to Unity and that's how you call it all the time. Okay, so let's start making this environment item because we need that. And is there, there you go. This is a float, but I'm not sure if I'm gonna have to change it later, but for now, let's keep it like that. So for this, we need an environment item, and it has a rect, which I will typically call a frame because that's what I'm used to call it from iOS. But let's call it a rect rectangle. Blocking, isn't this just a boolean? Why do they make it an integer? This is some C shit, I guess. Yeah, it seems like blocking should be a boolean. And I'm not sure we are gonna modify the environment. I'm just gonna make them lets for now. Blocking is a boolean. And then color is just the color. Okay, so now this compiles. And we can go back to the update player. So to update the player, we're gonna use the keys. Okay. With Raylib is key down left. Then what we're gonna do is change our position X. Player H or speed. The heck is that? It's player horizontal speed because the speed that it's a variable, it's just okay, that's just the vertical speed because you jump, and because there is gravity and acceleration with the jump, that's the only thing that needs to change dynamically through the update process of the game loop. The horizontal one is basically or it's on or it's off, it doesn't have acceleration. Okay, that's good to know. I think I'm gonna put them here. And I'm gonna make them lets, to be honest. I'm gonna call it jump speed. And let's say it's a float. 350 seems fine, I guess. I mean, I'm not gonna mess with the numbers. And this is horizontal speed. Okay. And let's make it clear that it's a float. Okay, so with this done, let's go back to the update player. So we can just take the horizontal speed, multiply it by the delta time. And the delta time is saying it's a double, but let's just confirm that with this thing here. So let me just confirm this. Delta time, it's Raylib get frame time, and it's a float. So I better put this as a float then, will make things easier. And of course, the vector 2. Oh yeah, well, it's immutable. Mutating. Cool. So that works. Okay, so we have done, what is the date? This part. Okay. So then this to go right is exactly the same, but instead of minus is plus. Okay. And now we work on the jumping. I feel like I should draw the player to make sure. Where is the player? So the player is just this guy. I guess I'm just gonna do here a draw. And I'm gonna just draw the player. I'm gonna make the player draw itself, I guess, for now. So the player rect, it's gonna be a rectangle. Okay, so let's start with the position X minus 20, because I guess 20, yeah, it's half the width of the player. Okay. So here it's again the same thing. Position Y minus 40, because you want the player bottom to be the bottom you are drawing, basically. So the feet of the player are touching the ground, even if it's just a square. And then you do 40 by 40, of course. Like, we should probably define constants for these things and all the stuff, but I'm not gonna worry about that. And here we just need to draw rectangle with the rect and the color red. Okay, so if I do here player, I don't have the player yet initialized. Okay, so initialize this here basically, right? Yeah, this thing. So after creating the window, I should make a player, the speed, so this is 400 by 280. The speed, it's gonna be 0, because remember this is the vertical speed, it's very confusing, I probably should change the name. And can't jump false. I don't understand why can't jump is false, but whatever. Environment, we don't have yet an environment, and the delta time it's okay. And now here, after clearing the background, I can just draw the player. Okay, so this should all this show the player, there you go, and I should be able to move it right and left. And we still haven't done the jump. And you can see that there is no acceleration, it's literally while I'm pressing the button, it's literally moving like that, you know, like I guess whatever is this speed per second, basically. Because we're using delta time to normalize that. Okay, that's a start. That is a start. That is a start. So let's continue with the player update. So now we want to be able to jump. Okay. So to jump, we check if the key space, so we're gonna jump with a space, but we also only jump if it can jump. If it can jump. Which we're initializing it to false, so we need to take a look at exactly how it is set to true. And now we set the speed to negative, because we're going up to the jump speed. And now we say that can jump is false, because we are jumping, so we don't support double jumping, basically. Okay. So this checks for obstacle hits, and then if it doesn't hit an obstacle, okay. Okay. So what I'm gonna do for now is, first of all, let me just remove these balls from here. I'm sure I'm just making sure I use this. And if I set this to true, I should be able to jump now, right? Or not? The thing is that I'm not updating the Y position based on the jump speed, so not yet. Okay. Okay. So I just need to go through, okay, for item in environment. I'm trying to read this. So if the item is blocking, which in Swift this should be actually called is blocking, because it's kind of like, you know, you're asking, is this environment blocking? Yeah, okay. And then what is this? Environment rect. Okay, so that's okay. So if the rect x it's less or equal than the position of the players x, and we just keep going with the checks. So item rect x plus, okay, so this is one side. Now we're gonna do x plus the width plus the width if the width is bigger equal position of x. Okay, and now we check the verticals. Drag y. Remember the y goes in the other direction, so check for the other sign. And item rect y plus minus, but what I just said is kind of better. Because it goes in the other direction, it makes things a little complicated. So now we need to check if the position plus, so this is what it's gonna be. So my current y position plus my vertical speed. I'm just gonna rename this. Vertical speed. Vertical speed. So if the y position width plus the vertical speed multiplied by delta time. Okay, if all of this, basically I hit, so it's a hit. Hit starts with false and hit starts, maybe comes through here. And then we reset the speed, the vertical speed is reset to 0. And the player position y becomes, yeah, the item rect y. So it's like, oh, it doesn't let you up. Never gonna move you. Okay, that's cool. Now, why is it not breaking? That's what feels weird. Like, shouldn't you be able to break the loop here? Anyway, I mean, the example is not doing it. I guess it doesn't really matter. Like, if there is not too many things on the environment, maybe we can just keep going. So now, if you didn't hit, then you can move. So your position y now can increase by the vertical speed plus the delta. So that's what basically is the same thing we're doing here. It's just that here we're kind of like computing it just for the check without updating it, right? In theory, we could make a copy of the player's position here locally, update it first, and then do the checks against that. You know, and maybe that changes a little bit, like, you know, I don't know, the performance profile of this function, but you know, that's for professionals, and we are just trying to play with this. So so that line is done, and now the vertical speed increases, which means goes like down, with the gravity, and the gravity in this example it's 400, so I guess I'm just gonna put it here. Now if I put it here, it's not gonna work. So, well, yes, I guess I can make it private to this file and say gravity 400, and I guess I can make it a float just to avoid conversions everywhere. So this should be gravity plus delta time. We're here. Okay. And yeah, so you pressed and we can say can jump false. Okay. If you didn't hit, you are jumping. So because you're jumping, we say that you're jumping false. But if you hit something, your stuff was reset already here, so the only thing we need to do here is jump through. It feels a little bit convoluted the way it's written, but for now let's just keep it here. So in theory, yeah, it's already falling. You didn't even see it. Okay. So the player is already immediately falling because gravity plays an effect, you know, and because there is no obstacles, like there is no environment items making it hit and resetting the speed and the position, you know. Okay, so we need to give a ground to this guy, but before that, is there something else I need to do with the player? Because this is the update player. This is all camera related stuff, which we're gonna do later. And then this is play, okay, camera. The player is just updated here, nothing else. And for drawing, we already draw the player. Okay. And this is just stuff. We can do that later because for now that's not important. Okay, cool. So okay, let's give this guy something to sit on, and we are gonna be making the environment. Cool. So what do we make the player here? So the environment is, I'm assuming we're gonna change it, so it's gonna be a constant, and we're gonna call this environment, and it's gonna be an array. It's gonna be an array of environment items. So I'm gonna make it an environment item with a rect of 0, 0, 1000. So I imagine this is the the floor because it's quite a big width, and 400 height. And remember, we're drawing always down. And wait, this is not blocking. Okay, right. It's weird, but okay. And here we have 0, 100. We have another 1000 here, so maybe this is the ground. So I'm not sure what's the other representing. And now we have true and gray. Okay, and we have 3 more. So we can do 300. These are just some random obstacles that they put here, just so you can, you know, do a platformer. So it's just a bunch of platforms, and the platforms are all 10 on height. So that's fine. And then this is at 250, 650, and 303. Okay, so these are the platforms and the floor and all that stuff. This doesn't matter because that's just because of C, and that's it. We can, this is all camera stuff, which we're gonna be later. And now the update doesn't do anything, right? With the, well, I need to pass it, of course, to the player here. To the player later. And now I just need to draw it. Okay. And to draw it, Maybe we could put the draw here too. We could put the draw here. I just want to copy it and see what are they doing. So this is just Raylib draw, and this is your rect, and this is just color. So it's quite simple. Okay. And now, just for fun, let's do something fancy and swifty and say if there is an array where self is an environment item, let's implement a draw function that basically goes through for each and calls draw. Yeah, I still hate that I cannot do that. Whatever. I would just want to say just draw, you know. And I could do it if I could reverse this, but yeah. Yeah, this needs to be an equals. No. Yeah. Wait. Generic generator. Yeah, of course it's not self. Sorry, it's element. There you go. So it's unfortunate I need to write it like this, but fine. And that means here on the game draw, before drawing the player, I can draw the environment, and it looks quite nice because this is like environment draw, you know, super nice. And in reality, this is an array, and the array has a draw function. Like, it's pretty nice, I would say. Since we're writing Swift, let's try to write it properly. And there we go. Okay, so the first one that it's light gray is just a background. Okay, but now we should be able to move and jump. There you go. And the math is actually letting us jump up, but not down. That's cool. I didn't realize when I was writing it. Well, I thought I realized something weird here, because here you're checking plus width, but you don't never do plus height, because you're actually just checking if you're coming from the bottom, basically. That's cool. Okay, so we have a platformer. Now, as you can see, the camera doesn't follow us, right? So that's the next thing. Make the camera follow us properly, right? And be able to control it a little bit with the zoom and all that stuff. So that's what we're gonna do now. Oh yeah, it's so fun, man, when you do your own things, even if it's so stupid. And the physics are just half of it. Yeah, this hit testing. I think Raylib has some basically collision detecting, you know, functions, so you can actually just use that in reality. But I guess that's for later. Cool. So now let's use the camera. And remember, we already did a tutorial the other day, which, you know, the videos are now on my YouTube channel. But the last example we did already used the camera, the 2D camera. So I think we're just gonna actually answer a question I had the other day, because I was saying, how can I do the typical thing where the camera follows you strictly only when you hit the borders of the screen, right? So in the middle of the screen, you can move freely, like for example, like the same thing I'm doing here now, right? So right now here I can move freely and the camera doesn't move, you know. And what I want is that when I hit this point, for example, the camera starts tracking me, right? But then if I come back to the center, it doesn't move exactly as I move, you know, which by default is what happens. So now let's take a look at how we can actually tweak the camera behavior to actually do this basically border stuff. But to start, we need the camera. So after making the environment, let's make a camera. And we're doing camera 2D. And let's say let's say the offset, it's just gonna be screen width by screen height. We're gonna offset to the center. And the target you want to follow, for now it's gonna be the bias position, so that's where you wanna start. And the rotation there is no rotation, and zoom it's gonna be 1. Okay, so that's the initialization. This is to change camera settings, so for now let's gonna skip that and let's just gonna make it so we actually have a camera. Cast these things to floats. Okay. And remember from the other day that to use a camera, we need to wrap our drawing code, which in this case is this, to actually be in the drawing in the camera's coordinate system, basically, because that's everything a camera is. It's like just a different coordinate system. So everything you draw at position 0 is going to be 0 plus the camera's position or minus, right? Because they move the other directions. That's pretty much what a camera is. Begin mode with the camera and end mode 2D, and that's it. So in theory, that's the only thing we need to do to do the camera. And of course, yeah, that's Raylib. Begin mode and Raylib. End mode with lowercase. So that's everything we need to have a camera following us. So if we move, it doesn't move. Because I need to update the camera, of course. I haven't done that yet. Okay. So the update camera, the normal update, yeah, you need to keep telling the camera where the target is, which is the player. You know, like we did this here, but this is not, you know, Rx. This is not reactive. This is just a game loop. So we need to keep telling the camera where the target is of the current player. The offset, we don't need to change it every time. I think so. But since we're going to be switching between camera modes, you know, it's not bad to do that. So I'm gonna do how I'm gonna do that. What I think I'm gonna do is just use Swift to actually extend the camera, right? And I'm gonna do updating function, and I'm gonna say update yeah, I guess update center. And the update center, the only thing it needs to do is say camera off. I'm already in the camera. So I just need to change my offset to be, again, okay, so the only thing I need here is, okay. Yeah. So this is kind of the wall dimensions, basically. So that's us updating, and then we need the player. So I'm gonna say player here. Which if we wanted to generalize this code and move it somewhere else, like, you know, we could just change the player for the actual position. And if we really wanted something else for the other modes, you know, some protocol or something like that. But for now, we just need to change the position. So for this, we can just say, oops, sorry, no, it's not position, target. So target equals player position. Okay. So that's the normal update. And as far as I know, they do this here. The zoom. It's this one. Ah, well, yeah, they do this thing. Let's ignore the zoom for now, and let's do here player update. After updating the player, let's do a camera update center with that player. How is called? Screen width and screen height. and this is player, and this is a float again. Yes. And as we can see now, the camera is following us. Basically the same way the camera from the previous tutorial was following us from the previous example. Literally just keeping the player on the center of the screen. Right? So that's just how this works. Okay. So let's do the zoom part, so I don't have to keep thinking about that. So we can just say the camera zoom equals, because we already did this the other day. So it's basically getting the mouse wheel move and multiply it by some small number. And then it's basically clipping it. Yeah, it's the clip. Is it a clip? What I did the other day? Because I remember I already had this. Target. Yeah, see? This is literally the same thing we're trying to do now. So then we clamp, sorry, it's not clip, it's called clamp, between 3 and the 25 one. Okay. And then if the user presses the key R, I think it's letter R, yes. We reset the camera zoom to 1 and then we reset the player position to 408. Okay. And then if we press C, that's where we're gonna start changing the camera options. But for now, let's not do that. So let's see what changed. So if we press C, what is C? Ah, no, not C. C is to change the camera modes. R is to reset, right? So we jump, boom, and we reset. Basically a teleport. Teleport. Boom. Boom. Okay, cool. So I think that's it for the normal camera mode. So now what we need to do is to implement the other modes, which is kind of like what I'm interested in. And I'm thinking, because it's making disclosures and all that stuff, but wouldn't it be nice if the camera did all of this? Wait, so many. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, okay. I thought there were like less different modes. I think what I'm gonna do is look at this. Let's think about this. But I think I have some ideas about the design I want this to have. So I'm gonna say camera mode, right? And let's have center, map edges, I will call it. And smoothed. And then follow player center horizontally. Update player center vertically after landing. Ah, so it just poof, and then when it lands, it's like, oh, okay, that's a weird one. Center horizontally. I don't know, with vertical on land, something like that. I don't know exactly what that does. Push camera on getting too close to screen edge. And push on edge. Something like that. I don't really understand what's the difference. And now here we can do strings. What is it? Custom string convertible. and we can implement now the description, and we can switch on self, and now we can return these things. So for wait, custom, what the heck is called? So for center we return player folder. For map edges we return, and I think I can just do this. So this in theory should render us what we want. Yeah, see the instructions. So right and left to move, space to jump, the wheel to zoom, and of course this is implemented to work on Windows, so on macOS it's reverse and it doesn't do it, right? Well, whatever, it's fine. And then the C to change the camera mode, which doesn't work, and the R to reset. Okay, and the current camera mode is follow players center. Okay, cool. So now that we have this, let's back to this. So we have the update method just working. Fine. Like the draw and the update are just working. We just need to implement something to actually change the camera mode, so we can do it here. So if Raylib is key pressed letter C for the camera, we can just say go to the next camera mode. For that I think I can just say here case iterable, and now I have the ability to iterate through. And is there something smart to do here? So I guess let index. I mean, I can do just self cases. Index after. Well, no, I need to get the index of self, right? And I can forecast it. And now I should be able to say can I do +1 to this? Okay, so I can. So I should say current index. Now next index again is the current index +1, and I can mod that with self all cases count. That's the next index, and now I should be able to say self equals raw value. Well, it's not a raw value though, it's self all cases next index. That should work. That should work. So I should be able to say, you press the letter C, the camera mode, and the camera mode should be mutable. And I guess I will change this to switch to next. Okay. You can see the camera description should change. The camera itself shouldn't, but it should. So where are the descriptions at the bottom? So follow center, but clamp the edges. Follow center smooth, follow horizontally, push the player, and now I should go back to the first one. Follow player, bam, 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 bam. Okay, so you can keep clicking C, and if I click reset, the reset doesn't reset the camera, is that correct? Yes, it doesn't reset the mode, just resets the zoom and the position. Okay, cool. Cool, so that's it. That basically switches to the next one. Which, to be honest, like this could be just an extension on a case iterable, basically. Which is basically going to the next one. Cool, that's nice. So now that we have this, and we know which mode run, we should probably implement on the camera a proper update for each mode. Right, so I'm gonna do mutating func update, and I'm gonna say update for mode and camera. Right, and I'm gonna switch on the mode, and still doesn't know which mode I'm talking about, but that's fine. I'm gonna just take this, right, and say if it's the center, update center. Cool. So now I need basically all the stuff. So I need all the variables and properties that basically that any mode can use, which is not very nice, but for now let's just gonna do that. Right, so for now I'm just gonna call them all with the same. Okay. So for now, doesn't matter which mode you use, that it's gonna be all the same, and I need to use that. So I'm just gonna do update here for camera mode, and I'm gonna pass it the player, the width, and the height. And then this method is gonna dispatch to the correct. Don't ask me why this. Bro, what's going on? Bro, what happens here? Okay. Anyway, formatting in Xcode. Okay, cool. So now we have this. Let's double check that everything runs. Still, I can do this, I can jump, I can reset, and I can change the mode, but doesn't do anything. Okay, cool. So now let's implement the other camera modes. See if we can actually implement them, and if I actually understand what they do. So this center inside map, it's how it's called. So I think I'm gonna do, instead of map edges, I'm gonna say, doesn't matter a lot, center inside map. That's cool. And here I'm gonna do update center inside map, and I'm gonna make sure I call it from this guy. Cool. Now what does this guy do? So it starts by setting the target and then the offset to this. So it does the same, right? And now it has a min x, min y. So that's kind of like the, the square. So it's min x. Okay. Min y of float, 1000, max x float, minus all of these are. So that seems like it's defining the coordinates to basically the camera. And I need the environment. Okay, let me do one thing. Center inside. Say what? Put clamp map edges. Player follow player center. Ah, okay. It follows the player until here, and at this point it's like, yeah, just get the fuck out. Okay, so that's not the one I was talking about. Okay. Okay. I see. I see. So it needs the okay. So it's just gonna make a bounding box with all the environments that there are on the map. So basically, it's like it just follows you exactly through the map objects. Okay. Okay, that's interesting. So I need to pass the environments. And it would be nice, to be honest, if there was like a way, like I don't like this math. That's cool, but I would like to have like this in a rectangle that represents the bounding box. But it's fine. So we put the environment here. This guy doesn't need it, but this guy does. So we need to pass here the environment. I probably made the typo twice, no? And now we need to pass here the environment. Environment. See what's happening with that. But okay, so now for item in environment, we say post. Okay. The mean x is equal to the mean there should be a mean between the item red x and the existing mean. Cannot assign. Yeah, okay. I thought we're just defining the bounding box, not that we had to compute it. And then we do the max for item rect x plus the item rect width versus the max x that we already have. And now we do the same for the y, min y, and now we do the same for the max y. There you go. Now, once we have this, what are we doing? Get world to screen 2D. Get world to screen 2D. Yes, okay, because these max and mins are based on the positions of the environment which it lives in world coordinates, and we want to convert that to screen coordinates so the camera knows what to do. Makes sense. So that's max Raylib get world screen 2D, and the position is max x and max y. And the camera, it's south. And min is exactly the same thing. But instead of the max x, it's min x and y. And now that we have this, we can finally go and change things to the camera. Okay, so that's this line. Man, like, I don't know why, like, C programmers prefer to do it, like, in line here. Like, this is so hard to read. I'm not used to that at all. I don't like it. But it's fine. So now, isn't this the same, but with y? And instead, use the height. And the max y here, and the height. Okay. That's one side of it. And now we do the other side. Keeping it quiet because, you know, this is like just copy pasting this, but you make a mistake here and oh, it fucks up. Okay, so now at least we should see the camera behave differently, right? So here it's just moving with us, and if we change to this mode, doesn't work. Okay. If we change to another mode, it works because it's the same. But when we change to clamp, okay. So we fucked up somewhere. Wait a second. Max x, min y, and max y. I think I did the lines properly, but I did this. So it's min x, max x, min y. Okay, did that fix it? C. Okay, that's perfect. So the camera doesn't. If we zoom a lot, the camera, it follows. No, it's clearly following until it reaches the. And it even goes up and everything. You know, but it stops following. It's like when you reach pop, it starts following. Okay. Second camera implemented. Let's go for the third one. Enter smooth follow. So let's call this center smooth follow. Okay. And seems kind of simple. So let's just take this one and let's call it smooth follow. Okay. But these are just some properties. Mean speed float 30. So this kind of like is this gonna be interpolating or some crap like that? Through, you know, like animating. That's cool because that's always. Fraction speed, okay. Wait to understand this one. So the offset of the camera gets reset all the time to this, but now the target doesn't change always. Okay, we do some stuff. In this vector subtract, isn't this just the player position minus the target? That works, right? Yeah. And then the length is the vector length. So if the length bigger than the minimum effect, so if you didn't move enough, it doesn't do it. But if you move enough, then it does it. So then we have the speed being the max between what? Between fraction speed multiplied by length and the mean speed. Okay. So at least you move at the mean speed. And then the target, is the current target plus the diff scaled by the speed multiplied by the delta time divided by the length. So that does like a follow, like a progressive follow. And delta time is not in a scope. Okay, I need to pass this delta time to all this. Okay. So let's say delta time, it's a float. Okay, now this compiles. Need to change this smooth follow for this one, which theory means this. And the main update needs parameter. Okay, that should be it, right? Let's try. So normal move, just move until the border, and this is the normal move, but with some smoothness. Right, so it goes with some delay, and then it catches up. That's cool. I feel like it's a little too small and too linear, I would say. Would be cool if, you know, if it followed you and then quickly catched up, and then it, you know, rested a little bit faster. But that's fine, like that's the example. Then it's like you go here and you can tweak like this formula, then, you know, that's up to you. Like it's mostly tweaking this formula, I would think so. Cool, next one. Update camera event out on landing. Okay, so what this one, I don't understand this. Okay, this is the and this is the smooth. Okay, so horizontally this one follows immediately, and then see, it doesn't move, bam. And then vertically you jump and when you boom. That's cool. Boom. That's cool. Every time you boom. Okay. That's cool. I'm not sure, I've never seen this. What is it? Event automatic. And what did I call it? Yeah, I call it like it's the weird name, right? Event. I'm gonna keep this name. I'm gonna even use it here. Okay. So, mutating func update center horizontal. I mean, it's a mouthful, I know, but tough life. So it has some things here like similar. So event out speed. So it's kind of like the same thing that this does, where it smoothly transitions there, but it only transitions there smoothly at the end. And it's only, for the, when you land. Event out target. Okay, I'm not sure what this does. But it's not initialized. I guess I'm gonna initialize it here. So then offset equals, this is the same thing all the time, right? Offset equals this. Is there any camera that doesn't set this? Because if if this offset never changes, like what is the point of doing it all the time? I don't know. And then the other thing is the target, but the target is only touching the X. So it's like this, like the normal camera, except it only does it on the X. Right? And now for the event, if evening, shouldn't it be even out? Event? Shouldn't it be event? I don't know what it means. Evening out. If even out target, it's bigger than the target. Okay, so if you landed above where we are now, then we just take the target Y, and we use the speed plus the delta time to go there. With that done, if we go to the target Y, target Y, yeah, this is a variable. Change the Y and that's fine. So then here, this one, there is an else where we change the target. It's like if you are below, well, it's like the other way around. That's not what I mean. It's like the same thing, but like negative. So the speed plus I multiply by delta time. And then if the target Y smaller than the target, we change the target Y bit. And we say that we don't evening anymore. And now outside all of this, there is an else here that says, isn't this just an else if, bro? If player can jump and player speed, which is a vertical speed, equals 0. And player position Y, it's different than the target Y. Then we say, okay, you landed, right? So let's start doing the animation to go there. And what's the target of the animation for the camera? Well, it's the Y position of the player, which is basically where you land. And that's why this is a bar. Okay, let's give it a try. Did I change it? What do you need? The delta, right? These ones that have animations need the delta time. Okay, so fixed camera following the player. This one it's following the player until the borders. Up. This one follows smoothly. And now this one should follow, but vertically doesn't follow, right? Until you land. And it doesn't. Think. So it's this one for sure, yeah. Like if I do this, oops. Okay. Ah, shit, because this is a static in C. Bro, that's why, because it's a static in C. So these bars. Yes, so see, it's like you do this, and now that sits like on the global memory, basically. So I guess what I need to do... Like we cannot attach this into the camera memory. I mean, I can just move it, you know, global scope on this file, make it private to this file, and that's it. And now it goes. I feel like there is something wrong though, because it doesn't... Yes, like there is something wrong, but I'm thinking, is this what I want? I mean, it's what the example does, right? So like the other alternative, it would be to attach this to the camera mode itself. So the camera mode can keep some state because it's the thing that happens. Yeah, I still think I would love to have mixins in Swift. You know, like I would love to say extend camera 2D, right? And say put this in there. Right? But extensions must not contain stored properties. But, you know, so that's what I call mixins, being able to add state through extensions. In my opinion, that's kind of like the name. There is another name which is similar, which is called traits. But for me, traits are about behavior, right? So Swift supports traits because you can extend the camera. And I mean, the same thing we did with the array here. Like we extended the array, you know, and we added a trait where say, okay, now this array, you know, in this specific scenario can have more functionality, right? You could do that with a protocol, so that's why I call it traits, sometimes. But for data, for state, for properties, you can't do that, and it will be very nice. And I understand why not, because it's like, where do you put this in memory? No? But it will be nice, if structs may, I'm not sure. I will love structs to have it too, but I understand why not, because the memory is specifically restricted and stuff like that. They could have a pointer to another separate kind of like table where these things are stored, which is kind of like what Objective-C did with the associated objects. But Swift doesn't have that. It will be nice, in my opinion. I think it will solve things like this very nicely. But for now, I'm just gonna keep it like this, right? And move on, because I think it's still not correct. So the even out the speed, oh shit, why is it 30? Of course it's slow. Fucking, it should be 700. I guess that's the difference that we were seeing. So this one. Land spam. There you go. Land spam. 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 Yeah. Okay, that's it. That was the issue. Cool. So let's tackle the last camera mode. Which for it, I'm just gonna copy the easy one. Let's remove the breakpoints. And let's call this update camera. Okay. Player bounce push. The heck? That I don't understand what this is. So this is the last one we did, right? No, that's the ground two edges. That's the smooth, and that's the horizontal only. Okay. And this one, player push camera on getting too close to the screen edge. Ah, that's the one I want. So see, in this center, it doesn't move. But if you close, that's the one I wanted. That's for me the most natural. And I will open, there is like a window here in the center that doesn't track you. I will make that window bigger. That's the one I want. I'm pretty sure that's I'm pretty sure that's kind of like the most used. So how's this player pushes the camera on getting too close to screen edge? Yes. So how are you calling that, bro? Player bounce. Player bounce push. I like this name. Player bounce push. Push on edge is what I called it. I'm just gonna call it the same for the sake of keeping it. Player bounce push. I'm not thinking going back to the state. Is there any reason if we did it with closures? Maybe if we had done it with closures like this and just call it directly through the closure on the array. Maybe that would have made it easier, because we could have kept those variables here and the closure would have been able to capture them and mutate them. So yeah, maybe I did usual, I wanted to design something before actually using it, and it turns out I probably make it harder to myself, because now I don't have a solution for this. It would be nice to try to implement the same with closures, and maybe it's it. And it's not that hard, to be honest, because I can just pass these things as in out here, and then it doesn't matter. I can just do a little refactor and actually have it working. Let's not do it for now, but it may be worth. So for now, let's just do this and update the last one and see what we need to do. Okay. So exactly. So first we make a bounding box. box, which is basically 20%, I guess this is. I guess this is 20%. Okay, let's just remove this for now. Yeah, look, this is the only method that doesn't change the offset like all the rest. So that's the reason why all the rest need to make sure they reset it every frame. Okay. And the bounding box, let's make it bounding box. I'm gonna be explicit with the name vector 2 and 0.2, 0. Okay. Get screen to be. Let me take code so I can just go full screen. Okay, so now for this, the x will be 1 minus the bounding box x. So hard to read with all this crap from C. Oh, shit. Oh, I'm tired. .5 multiplied. Okay. And for the y, also bounding box y multiplied by and the gamma is yourself. Okay. And the max, it's and now we just need to change the a little bit of multi-edition here, so the player position, all this is, and that's a mess as always. I'm gonna do it from the other side. This is way. I'm not like super proficient in this kind of editing. Something that the more, as the older I get, the more I think I need to pay more attention to. So this should work. So it's basically first. So let's recap. Let's recap. So we have the bounding. I can get rid of this. So we have the bounding box as kind of like a percentage of what we really want the player to be able to follow. And once and then we calculate from the screen coordinates to the world coordinates to know when the player had reached that, basically. And that gives us the minimum and the maximum bounding box where we should follow the player, basically. So it's like a rectangle with a smaller rectangle, so on the borders between them, that's where we follow the player. And then we put the offset of the camera to that, and then we check, is the player in one of those cases? Then we move the camera target to the player's position on these cases. So let's give it a try. Let's give this a try. Let me change the camera. So it should be the last one. This is the smooth camera. This is the one that jumps up. And that's the one that, yeah, see? So if I move here, it doesn't track me. And as soon as I start pushing this invisible box, whoop, the camera starts tracking. And it's the same for vertical, if you noticed. So you see how until I don't, like there is kind of a line here, whoop, that it starts. It would be nice to draw it. Maybe it's worth to draw it. Maybe it's worth. And it shouldn't be that hard, right? It's kind of hard because I'm not on the drawing context at this point, because the update happens before the draw, so I could expose that somehow. Let me see, is there an easy way? So isn't min giving me the minimum x and the minimum y and max? Yeah. I may do some BS here, so it's kind of late, so maybe we cut it here, but now I'm just curious if I can. So if I take the x, don't I have to do this? Like I'm trying to reverse the box. Like it would be easier if everything was with I think with a rectangle instead of having these things as vectors. But anyway. And now I need to go through a global variable because I'm not in the correct place, but it's just for debugging purposes. Exactly. So you can see how it just goes outside. If you stay inside, it's fine. But as soon as you try to leave, that's cool. I like that. I like that. Okay, so I think I'm gonna leave it here for today. That's exactly what I wanted to accomplish. You know, and if you change the camera, I should probably not draw it, but whatever. So we have a platformer example from Raylib ported into Swift, you know, with multiple cameras and all that stuff. And I finally understood how this works. Right? That's the camera I wanted to actually see working and how it worked. The other cameras are like, yeah, nice to have and stuff like that. But the one I wanted was really this one, because that's what platformers actually do in practice. So I'm very happy to have this. And just to end it, let's just kill our player. See ya. Cool.